physical properties of metals. Our Earth consists of several metals and non-metals. They may occur naturally as elements in the Earth crust. For example, zinc, mercury, gold, copper are few examples of metals. Phosphorus, graphite and sulfur exist as non-metals. 118 elements are known so far, which are listed in the periodic table as metals, non-metals and metalloids. Metals are placed on the left-hand side, non-metals on the right-hand side, and metalloids occupy the intermediate position between metals and non-metals. Copper was the first metal to be used in making utensils and weapons. Metals have a significant role to play in our daily life. They are employed for construction of bridges, automobiles, ships, trains, buildings, etc. Metals like titanium, chromium, manganese, zirconium find application in manufacture of defense equipment because they are light and can withstand wear and tear and also are not corroded if kept in air for a long time. These are called strategic metals. Uranium is most expensive since it plays vital role in nuclear explosions, resulting in enormous amount of energy called nuclear energy. Copper, silver and gold are called coinage metals and are used in making coins, jewelry, etc. Let us learn about the physical state of metals. All metals are solids at room temperature. Mercury, that is Hg, is the only exception. It is liquid at room temperature. Gallium has a low melting point. It melts when kept on palm of the hand. Density of metals is high. This is because in metals, atoms are closely packed. Osmium is the densest metal. Platinum, gold and lead have high densities. Only sodium, that is Na, and potassium, denoted by K, have densities less than water. Thus, all metals are hard materials except sodium and potassium, which are soft metals. Lead is also considered to be a soft metal. Because metals are hard and very strong, they can bear a heavy load over them. This property of the metals is being used in the construction of buildings, bridges, and heavy machines. Metallic luster. If we observe freshly cut surface of metal, we will notice that it has a shining appearance. This is called metallic luster. When we rub the surface of a clean copper rod with a sandpaper, we find that copper has a shiny surface. So we conclude that all metals have a shiny surface. These can be polished. This shine is due to the presence of free electrons in them. Free electrons absorb light and jump to higher orbit. When they come back to their original orbit, they emit radiations. That is why the shining surface is due to this. Some metals have more shine than others. Gold, denoted by Au, silver, that is Ag, copper, that is Cu, and platinum, that is Pt, are such examples. Others can be polished to give a good luster. Aluminium, when exposed to air, forms protective dull layer of aluminium oxide. Copper, when exposed to moist air, gets coated with a green layer due to the formation of basic copper carbonate, that is CuOH whole twice, CuCO3. Silver acquires a black shade due to formation of silver sulfide. This is called tarnishing or corrosion. Gold and silver are inert metals. There is very little, rather no effect of air and water on them. So these metals remain ever shining. Malleability and ductility. Metals are malleable. Metals can be hammered or beaten into thin sheets without breaking. Malleable means that metallic bonds in the metals do not break easily. They rearrange to form sheet. Gold, silver are highly malleable elements. Silver foils are used to decorate Kaju burfis. Metals can be melted and drawn into thin wires. Because of this property, metals are known as ductile. The ductility property follows from the malleability property. While being drawn into wires, metals are stretched. Because of the strong metallic bonds, the metal atoms do not separate easily. Silver, copper, aluminium are very ductile. Very thin wires can be made out of these elements. Electric bulbs have filament made of tungsten. Iron wires are used in preparing wire gauzes. Metals are highly tensile. Due to their ductility and malleability properties, metals are very strong. Their bonds do not break easily as the electrons are shared over an array of metal atoms. This gives metals a very high tensile strength, and so they do not break easily. Let us now discuss about brittleness. Metals are not brittle, but zinc, that is Zn, is an exception. Metals do not break easily because of their metallic bonds. Electrical conductivity. The animation here shows the electrical conductivity of metals. A copper wire is taken. Let us have a look at what actually happens inside a copper wire. Nucleus with completely filled shells of copper atoms is depicted as brown balls. Green color depicts free electrons. These electrons are free to move. When the current is switched on, we find that electrons move from the negative to positive terminal. As the electric current flows across a metal, it becomes conducting. The conduction of electricity by metals decreases with rise of temperature. This is because metal atoms consist of free electrons of the valence shell and the remainder positively charged part called kernel. With increase of temperature, kernels start vibrating, creating hindrance in the flow of electrons. silver, copper, aluminium are good conductors of heat and electricity. Amongst metals, lead, that is Pb, is a poor conductor of electricity. Mercury too is a poor conductor of electricity as it offers maximum resistance to the flow of current. Silver is the best conductor of electricity, followed by copper, gold, aluminium and tungsten. As tungsten has high resistance and high melting point, it is generally used for making filament of incandescent lamps. Let us perform an activity to understand it better. Set up an electrical circuit consisting of a battery, bulb, switch and clips as shown on the screen. Place the metal strip whose electrical conductivity is to be checked between the clips A and B and switch on the circuit. When the strips of different metals like aluminium, iron or copper are put between the terminal clips, the bulb glows on completing the circuit. So, we conclude that iron, copper and aluminium are good conductors of electricity. Thermal conductivity. Amongst all metals, silver is the best conductor of heat. Copper comes next in conductivity of heat. Aluminium is also a fairly good conductor of heat. Because of their high conductivity, they are used for making utensils. Silver is more conducting than copper, which is more conducting than aluminium, which is more conducting than lead, which is more conducting than mercury. Let us conduct an activity to show metals are good conductors of heat. For this, we take a copper or aluminium wire and clamp it on a stand as shown on the screen. We then fix a pin to the free end of the wire using wax. Next, we heat the wire with a burner near the place where it is clamped. We find that the wax melts after some time and the pin drops down. So we infer that copper or aluminium wire is a good conductor of heat. This also means that heat travels from the hot region to the cold region of the wire. Melting points and boiling points. All metals other than lithium, sodium and potassium, cesium and gallium have high melting and boiling points. The melting points of sodium and potassium are below 100 degrees Celsius. The melting point of iron is about 1540 degrees Celsius. Tungsten has the highest melting point, whereas silver has low boiling point. The melting and boiling point of a metal depends upon the strength of its metallic bond. Metals with weaker metallic bonds are having low melting and boiling points, while metals with strong metallic bonds have higher melting and boiling points. Metals are sonorous. Metals make a characteristic sound when hit with an object. Thus, metals are sonorous. It is due to this property that metals are used for making bells, strings of musical instruments like sitar and violin. When a metallic coin falls on the floor, it produces a deep, ringing sound. The sonorousness of metals depends on the temperature and density. Let us revise. Metallic luster is the ability of a metal to reflect the light falling on it. Metals lose luster if kept in an atmosphere due to the formation of oxide, sulfide, or carbonate layers on them. Metals reflect light at all angles and therefore can act as mirrors. Malleability helps in achieving a desired shape in the metals with hammering. Metals can be drawn into thin wires by stretching. This process is called ductility. Most metals are good conductors of heat and electricity. Metals are sonorous.